So this last section is more regression. This is why I had you guys do a regression review after the quiz. We're just going to do some examples together, and then you are going to do some examples. These are all AP problems. This section is rarely tested on the AP test, but it is possible that you would get a question or two. So let's start with this one, this question 6. The stats department at a large university is trying to determine if it is possible to predict whether an applicant will successfully complete the PhD program or will leave before completing the program. The department is considering whether GPA in undergraduate stats and math courses and mean number of credit hours per semester would be helpful measures. To gather data, a random sample of 20 entering students from the past 5 years is taken. The data are given below. Okay, so what you're going to see is every student is given a letter, and from that student, we looked at their GPA and their credit hours. And it is split up by those who completed the PhD program and those who did not complete the PhD program. At the bottom, the regression output at the top of the next page resulted from fitting a line to the data in each group. The residual plots not shown indicated no unusual patterns, and the assumptions necessary for inference were judged to be reasonable. Before we look at the next page, residual plots indicated no unusual patterns. What information does that give us? Why were we told that? What does a residual plot assess or measure? Nobody remembers? Got nothing? Avery? If what is random? Not quite. We want the residual plot to be random. And if it is, if there's no pattern, that tells us something. Kanan?
I was going to say it's students.
Okay.
And
Kushi, what were you going to say?
Correlation.
What about correlation?
Like if it's like scattered.
If our residual plot is scattered, what does that mean?
There's a linear relationship.
Okay.
that's what we're
Okay. Random residual plot, so maybe write this down. Random residual plot. We have a residual plot after our regression, after a line. So a random residual plot tells us that the line is a good fit to the data. That our line is a good fit. And then the other thing I want to review, when it says inference, what is that referring to? Inference? Josh? Say it again. Say it one more time.
Conclusion.
Okay, yeah, a conclusion using what?
Like your hypothesis.
Okay, great. Inference means a confidence interval or a hypothesis test. So it's telling us the assumptions, aka the check part, is met for a confidence interval or a hypothesis test. So really what's new today is we are looking at confidence intervals and hypothesis tests for slope. We okay on this? Okay, so let's look at the next page. We see all of this output at the top. I want to talk about the things that we have already looked at. So the numbers that you need to be able to identify and interpret. If we just look at those that successfully completed the program, you need to know these two numbers. You need to know this number, and you need to know that number. Those are all of the numbers that you should be able to identify. What is that 23.514? Okay, the constant. What's the algebra word for that? Because it says they're both constants, Josh. Huh? Okay, yeah. What is the negative 2.7555? Slope. So then what is the 23.514 if it's not slope? Y-intercept. Okay, this S, sometimes written as SE, this is R squared. So you need to be able to find and interpret all of those. The new ones that we're going to look at eventually are this one and this one. So these are the new ones that we're going to take a look at. Okay, if we do part A, use an appropriate graphical display to compare the GPAs for the two groups. So we need two graphs, GPA for PhD, GPA for didn't complete the PhD. What is one graph that we could use to compare two sets of numeric data? Okay, we could use box plots. What else? Come on, there's at least three more.
Box plot.
Oh, histogram, stem and leaf, dot plots. I'm not actually going to do that. Are you comfortable constructing a dot plot? A dot plot for did complete the PhD program, dot plot for did not complete the PhD program. And then what would we talk about in general when it says comment on the display?
The relationships, whether it was strong, linear, or
That would be if it's a scatter plot. Guys, come on, this is like one of the first things we learned.
Exactly, it's been a while.
Josh?
Like center, size.
Thank you. Center, shape, spread, unusual. Write that down. Write that down. Okay, so we good on part A if we were to actually do it. I'm not going to have us do it, but if we were to actually do it. Okay, let's talk about part B then. For the students who successfully completed the PhD program, is there a significant relationship between GPA and mean number of credit hours per semester? Give a statistical justification to support your response. Okay, this is the new part. This is the new part. Is there a significant relationship? What that's really saying is we want to know, is the slope not zero? If there is a significant relationship, then our line is not going to have a slope of zero. Now, if we think about a slope of zero, if I have my plot, slope of zero would be just a horizontal line. So we would have dots that fall around this horizontal line, and this would be GPA, and this would be number of credit hours. Now this shows no significant relationship. So let's talk about why. The reason this shows no significant relationship, because as GPA increases, there's no change in credit hours. So GPA cannot be used to predict credit hours. Again, as GPA increases, credit hours doesn't change, so GPA cannot be used to predict credit hours. That's why we want to know, is our slope not zero? If we are looking for statistical evidence, we're doing a hypothesis test. We're not doing the whole test. We're going to do the null and alternative, the test statistic, the p-value, and we're going to write a conclusion. Okay, so here's what we do. Beta is the true slope for the linear relationship. True slope for the linear relationship between GPA and mean number of credit hours per semester for all students that complete the PhD program. We only have a sample, so we don't have beta. Beta would be if we talked to every single student who ever completed the PhD program and got this data from them. So our null is we are going to assume that there is no relationship. So we are going to assume that beta is 0, that the slope is 0. Bless you. And we are going to look for evidence to the alternative. There would be a significant relationship as long as the slope is not 0. Could be positive or negative. Okay, so we are doing a t-test for slope. We were already told that the assumptions or the conditions are met. So we're going to do our test statistic. Okay, test statistic is always sample minus parameter. Sample slope is little b. Population slope is big beta. And then here's the one that changes. And I'm going to be honest, I don't know if this is on your formula sheet or not. It's not on your formula sheet in a helpful way. In the denominator is always standard error. In that case, or in this case, it's S sub b. We do not divide by root n. So that is the weird thing with this, is you don't divide by root n. Okay, so if we go up to our output, this is the line that you're looking for. We have our slope here, and this is that standard deviation or standard error. So those are the two numbers that you would use. So if we go to do that, we're going to get negative 2.7555. Beta is 0. That comes from the null. And our S sub b is 0.4668. And that ends up being about negative 5.91. Negative 5.91. Now, that number should not be a surprise. Negative 5.91 should not be a surprise. And here's why. If we look at the output, it gave us that number right there.
It already did the math for us.
It already did the math for us. And what do you think P stands for?
Probability.
P-value. P-value. There's our p-value. So we already know the p-value is 0. Okay, so we get a p-value of about 0. So then we would show our p-value is less than 0.05, so we are going to reject the null. And if we write a conclusion, I reject the null. As there is significant evidence of, and then I'm just going to copy the wording directly from the question. Significant evidence of a significant relationship Can somebody open that, please? Thank you, Bethany. Between GPA and mean number of credit hours for students completing the PhD program. I do want to interpret the p-value as well. So I do want to interpret the p-value as well. So 0 is the probability, bless you, of a sample slope of negative 2.7555 or more extreme if the true slope for the linear relationship between GPA and mean number of credit hours is 0. And sometimes I write that the other way. Sometimes I write, if the true slope is 0, then 0 is the probability of this sample slope or more extreme. How do we feel about that part B, the hypothesis test part? Okay. Do we have questions before part C? Do you guys have it in you to do part C with me and then we'll take a break? Yeah? Okay, let's take a look at part C. If a new applicant has a GPA of 3.5 and a mean number of credit hours per semester of 14, do you think this new applicant will successfully complete the PhD program? Give a statistical justification to support your response. Okay, so if we look at these equations, or these two models, what we're looking to do is each model is looking to input GPA to predict the other variable. So if we input GPA, can we predict number of credit hours for those who did not complete the program? If we input GPA, can we predict mean number of credit hours for those who did complete the program? So we don't want to take a look at this student and then just look at the data on the first page. It's not appropriate to compare this one student to the data on the first page. We need to use all of the students. So what we're going to do is we're actually going to write this equation and see how the student fits in. So if we look at completed the program, 23.514 is the y-intercept, negative 2.7555 is our slope. Same thing down here, y-intercept, slope. So I'm going to have to move to another page to make sure I have enough room. Okay, so our student has a GPA of 3.5 and number of credit hours is 14, I think. Okay, so those who completed the program. The model from the previous page was y hat is equal to 23.514, subtract 2.7555x. And those who did not complete the program is y hat is 24.200, subtract 3.485 times x. In both cases, x is the GPA, and y hat is the predicted mean number of credit hours. Okay, we good on the models so far? So here's what we're going to do. We are first going to take this model and plug in a GPA of 3.5. So we get 23.514, subtract 2.7555 times 3.5, which gives us a y hat of 13.87, about. I did a little rounding. Then we're going to take the model for those who did not complete the program and also plug in 3.5. So we're going to get y hat is 24.200, subtract 3.485 times 3.5, and we get a y hat value this time of 2.00. So our ultimate question is, do we think this applicant will successfully complete the program? So based on those two numbers and the data from our applicant, what do you think? Does it look like this person will successfully complete the program? Sage, thank you for nodding your head yes. Why do you think? Can you give me one more sentence?
Above predicted value.
Okay, great, thank you. The applicant actually has 14 credit hours. That is much closer to 13.87 than it is to 12. So we would say, yes, the student will likely finish the program. As 14 hours is much closer to the predicted number of hours for students completing the program compared to those who did not. This is one of those question sixes. This is one of those questions where it has stuff that you know, but then also you are adding on to that. So this part C is kind of the investigative part, the part that stretches what you know.
Could you just scroll this so it's all on screen? Thank you.
Okay, any questions on that? So let's go to the next question. John believes that as he increases his walking speed, his pulse rate will increase. He wants to model this relationship. John records his pulse rate in beats per minute while walking at each of 7 different speeds in miles per hour. A scatter plot and regression output are shown below. Before we even look at part A, if I were to ask you to describe the relationship between speed and pulse, aka talk about the scatter plot, what would you discuss? What would you talk about? What? FUDs. FUDs, write that down. Okay, FUDs is only for a scatter plot. That's the only time. What does the F stand for? Form. So what we mean by that, is it linear or nonlinear? What does U stand for?
Unusual.
Unusual. That is anything unusual. Are there gaps? Are there clusters? Is there an outlier? Bless you. What does D stand for? Direction. That just is the slope. Is it positive or negative? And what does S stand for? Strength. And then on the topic of unusuals, do we remember the 2 types of unusual points? Or one of them?
I know there's
There were outliers and then like gaps.
So outliers 1,
Clusters.
points. Okay, so if I fit my line right here, about,
I know there's 2
this
types of
point is an outlier because it has a very large residual. Outlier has a large residual. What do we call it, on the other hand, if there's a point that maybe follows the trend, maybe it doesn't, but it's really far off in the X direction?
Influential point?
Influential. That is an influential point. And it's influential because it influences what?
The slope.
The slope or
String. Slope.
R.
R.
An influential point influences the slope and or R. Okay, so now we go to our output. Parts A and B, you already know. Part A, write the equation of the regression line. We got that. Speed is our x. So this then is the coefficient on x, aka the slope. 63.457 is our y-intercept. So we have y hat is equal to 63.457 plus 16.2809x. And x is speed, and y hat is predicted pulse. Okay, part B. Do the estimates of slope and y-intercept have meaningful interpretations? If so, provide interpretations in this context. Okay, if we start with y-intercept. Y-intercept is the point 0, 63.457. Is this meaningful, that point? What does the 0 mean?
He's not walking.
He's not walking. If he's not walking, 63.457 is his pulse. Is that meaningful?
Yes.
Yes. Okay, so putting that in words, what's his name, John? When John isn't walking, his pulse is predicted, you have to have that word, predicted to be about 63.457 beats per minute. And we've talked about that. On the AP test, you're not going to get credit if you don't put units. That's something really easy to leave off. And then our slope. Our slope is that 16.2809. That is the change in y over change in x. So I like to write it as 16.289 over 1. So when x increases by 1, y is predicted to increase by 16.2809. Okay, when John's speed increases by 1 mile per hour, his pulse is predicted to increase by 16.2809 beats per minute. Okay. None of that is new. Questions before we take a look at part C, which is the new stuff. Okay, part C. John wants to provide a 98% confidence interval for the slope parameter. Compute the margin of error that he should use. Okay, so idea for slope, or confidence interval for slope. It's always going to be statistic, so sample slope, plus or minus. Slope uses t, and then it's standard error of the slope. Margin of error is everything after the plus or minus. So this is the margin of error. Okay, so if we go to our output, this is our slope line. So S sub B is this number right here. Before, you notice it was called standard deviation. It also might be written as standard error, either one. So it's that 0.8192. Okay, so if we go down, T, I'm going to leave blank. S sub B is that 0.8192. For T, we find that on the table. This is the one weird thing. Every other time we've used T, it's been n-1 degrees of freedom. Slope is the only time that we use n-2 degrees of freedom. We were told in the very beginning paragraph that there were 7 observations or 7 points in time, 7 speeds, I think. So we are going to use 5 degrees of freedom, and then you would look on the table at 98%. Do you just trust me if I tell you what that number ends up being? The T value ends up being 3.365. So when we multiply those, we get a margin of error of 2.7566. Okay. I'm going to take like 4 or 5 more minutes to actually find the interval, even though we weren't asked, because you do need to know that for your assessment on Thursday. Questions on that before we find the interval? Okay, so if we go to find the interval, the sample slope, if you were to look at the output, is 16.2809. It then would be plus or minus that margin of error that we found. So that confidence interval ends up being 13.52, comma 19.04. That is our confidence interval. Do we feel comfortable interpreting that interval? Okay, can you all take a minute to interpret that interval, please? Take 1 minute to interpret that interval, keeping in mind that is a confidence interval for slope. So this is the interpretation of slope. I am 98% confident that the true slope for the linear relationship between walking speed and pulse is between 13.52 and 19.04, and somewhere we need to have units. Slope is y over x, so beats per minute over mile per hour. Or you could have put that walking speed, miles per hour, and pulse, beats per minute. You could have put it there as well. Okay, last thing before we take our break. The question says, John believes that as he increases his walking speed, his pulse rate will increase. Can we address that hypothesis based on our interval? John believes that as he increases his walking speed, his pulse rate will increase. Does our interval support that idea?
Yes.
Yes. Why? Bethany.
Because all the values in the interval are above 0.
All of the values in our interval are above 0, are positive. Thank you, Bethany. And then if you were asked something about what does it mean that 0 isn't in the interval? Because 0 isn't in the interval, there is evidence that yes, there is some type of useful relationship. How do we feel? Great. What we should have gotten from this today is a bit of review, and we should now know how to do the computations for a hypothesis test and a confidence interval for slope. We should be able to read the output, and we should be able to interpret the results of both a hypothesis test and a confidence interval. Do you have any questions for me? Okay, there are 2 questions left. We don't have time to do both of them. So what I would like you to do is find question 4. So we're going to skip 3 and find this question 4. What I want to show you with this question 4 is that this question 4 is a question 6 on the test. So the one that's numbered 4, but it actually says question 6. So this is one of those ones, again, where the beginning you're going to know, and then it's going to ask you to put together your knowledge in a little bit of an unusual way. This question is worth more than the other 5 questions, and you should spend about 25 minutes on it. I'm not going to give you 25 minutes. I'm going to give you 20 minutes with the people around you. I'm not going to help. I just want you to do the best that you can to get as far as you can and write something for each part. Is that clear? Don't use notes. Just get through what you can. You have until 9:40 with the person next to you. Good luck. Here are answers from another teacher. So this is not the AP rubric. This is just another teacher key. If we look at A, the slope is 0.165, but hopefully you noticed that was in thousands. So you either needed to say 0.165 thousand or multiply by 1,000 to get $165. So for every square foot increase, the price of the home increases by $165. What is missing here? One really big thing.
The y-intercept. Do we have to talk about the y-intercept?
We do not need to talk about the y-intercept, but thank you. Oh, guys, so important. What's missing? I talk about it every single time we interpret slope and y-intercept. No, the context is there.
Shoot. I don't know.
Josh?
It's there.
That's there. Is this true for every single house? Is every single house going to follow this pattern?
No.
Right, so how do we account for that? Who said that? Yes, thank you. Is predicted to increase. You have to say predicted, on average, tends to, something like that. You will not get credit if you don't say that. Okay, next one. Part B, the residual of 49. This house was priced $49,000 higher than what the model predicts for its size. Hopefully you said for its size. And then this was the key. If you look at the houses with a swimming pool, the residual is 18.6 thousand. So the houses with a swimming pool generally are priced 18.6 thousand higher than the prediction. Without a pool, it's a negative residual. So those have a price 8.8 thousand below what the model predicts. And if you find the difference, 27,400. I am so sorry. I will get through this quicker. We should have said no in D because the interval has 0 in it. And then that's what we got for part E. Okay, can I move on real quick? Any questions on that?